Okay, now let's try to set up to be able to spawn projectile from the weapon when the agent is playing the fire clip. So let's go back to our enemy agent group here. So if you remember on the anim sequence we added a fire bull metadata on the right hands of the mannequin. So we need to transfer this metadata to the weapon. So the first step is to we need to basically transfer the metadata from the hand to the actual agent, and we can do that with the copy metadata. So remember to set the behavior ID to 4 here. Now we want to copy basically the fire from the hands our joints to an actual fire metadata on the agents. Okay, so compile this one. Also change the states. Yeah, it's already in fire mode. Save. And now let's press play. So let's have a look with the debugger. Press 3. And let's see. Yeah, if you see, there is the fire metadata there. Okay, so now we have the fire metadata on the agents, on the enemy, and now if we go on the weapon, on the sync module, so we can transfer that. So first let's add the fire metadata. Add metadata. This one will be my fire. It's a bool, false. Let's set the behavior order to 3. Remember to turn on the agent creation only, and then on the sync module, go expand the metadata name. These are the metadata that is synchronized, so it's transferred from the parent agent to the mannequin agent to the weapon agent. So we need to add a new one and add the fire. So save, let's have a look. Turn on the behavior, we are on the weapon, and yeah, now we see we are the fire on the weapon as well, also on the mannequin. Okay, so the metadata is there. We can use it to fire the projectile. So to do that, we can use the behavior tree. So go to the Atoms. Let's create a new behavior tree. Let's do Atoms crowd and create a new Atoms. Let's create a folder. Behavior trees, and here create an Atoms behavior tree. Let's go Atoms BT weapon. Create also a blackboard. Atoms weapon. Let's open the behavior tree. Let's select the blackboard. So the behavior tree is really similar to the real behavior tree, but this is run for each agent, and also run multiple threads. So every agent is computing its own behavior tree using multiple threads. So okay, let's go to the blackboard first. So here we need to expose two attributes. One is the fire metadata. So let's go the key fire. Now we have the fire that is a metadata on the agents, and we need to use this inside the behavior tree. What we can do is for the key here in the blackboard, we can link this key to the agent metadata. So we just need to switch here the use metadata in link mode. In this way, when the behavior tree tries to access this key, the value of this key, it will read directly the agent metadata. If you want, there is also this cache mode. This one is more useful for, especially for direction, if you are going to change direction from multiple nodes. What the cache does, basically, instead of the link that just access and set directly the metadata, if you are using for example, the set blackboard entry task or on any other nodes that set this a value on this key, it will basically write directly to the agent metadata. In cache mode, basically, the value of this metadata is stored inside this key before the agent compute the tree at every tick. So if you try to access this value, it always has the initial value. So if you change this value from if you read and write this data from multiple nodes inside the tree, it will basically read always the unmodified data from and then basically after the tick of behavior tree is finished, the agents copy basically the data inside this key to the actual metadata. But in this case, we want to set directly the metadata, so and access the active metadata, so put a link. Then we need another entry that is called active. Active. And we need to link this one as well. The active metadata is an integer and is controlled by the rector module. Basically, in this case, controlled by rector module, but it can be used basically to disable the computation of the pose of an agent. And the rector module use this active metadata. So I change this active metadata when an agent enter in the rector mode. When the agent enter in the rector mode, then this one will go to -1, and so we need to be sure to not basically continue to fire and create new projectile from the weapon, even if the agent is already dead. So okay, so our blackboard is ready. Let's go to the behavior tree. So first things, the Atoms behavior tree doesn't work like the Unreal one. So you need basically to create a repeat node, because otherwise, as soon the root node returns success or failure, the agent stops to execute this tree. Instead, with the real one, it's execute again if the computation is finished at the tick before. In this case here, we want to always run this this tree. So I can put it and repeat forever here. Then we can put our first conditional. Actually, this conditional can go up here, so we can stop when we are in active, when the active is off. So on each node here, you see all the parameter, and then when you see this small blackboard icon, means that you can override these values in a blackboard key. So if you switch that, you switch in a blackboard key mode here. So for example, here we want that this tree is computed when the active is higher than -1. So it's actives are integer. We have higher, and then here we can connect the active blackboard key, and then here the value is -1. So as long this one is -1, sorry, so as long the active is not -1, it continues basically to execute the tree. This one is dynamic. In the dynamic mode, basically, it continue check at every tick if this condition is true. Otherwise, just stop and return false. So the repeat continue to execute the children. Then we need an optional node. The optional just return always, even if return success, even if the child return failure. And then we need another condition. Sorry, not condition, but a conditional decorator. So as you can see, those nodes are all decorators. So the decorator basically just run its children based on some condition. And in this case, the conditional basically is a decorator that run its child if the condition is true. And here we need to check basically if the file metadata is true. So basically here our file metadata is a boolean, and we need to link to the blackboard that contain the data. So it's a file, and then basically we need a cooldown. So the cooldown basically prevents from executing the children too frequently. In this case, it waits basically 1 second before executing again the children. So here just put 1 and use a second, otherwise it will be just one tick. And then now basically we need some custom task that in some ways spawn the new projector from the weapon. There is no task ready that you can use directly. So here we have all the list of our tasks, but we can create one in Blueprints. So let's create a new task. And here let's save for now. Save this one, and let's rename this one. And let's call Behaviour task fire project. Okay, let's save this one, and now we can add our custom task. Let's rename here fire project. Projectile conditional. Let's call this one is fire. So just check fire. Is active. Okay, let's go to our task. So the task, we need to implement the event, the update event. Here you have multiple events that you can override. There is the initialize and terminate, but in this case it's just a task. So yeah, only we can do everything in the update, and then we have the set success state. So this is basically let's put a print here so we can check this one is working. Okay, let's save. Now this tree that doesn't do anything particular, but let's just use it to test if all the condition is working fine. So let's go to the agent group weapon. Okay, now in the weapon we need to add a behavior tree module. Let's attach the behavior tree. Let's change the behavior order to 4. And then we can attach our weapon behavior tree. As you can see here, there is also a blackboard entry that can use as a global blackboard. And this one is used basically as a parent of the actual blackboard here on the behavior tree. And this is the data stored in this blackboard is used for every agent. So since each agent has its own instance of this tree and its blackboard, instead this one is a global blackboard. So there is only one instance inside this behavior module. And you can access the data stored in here from your behavior tree here. Okay, let's save this one. Let's have a look. Okay, this one is working. So let's take, as you can see, something is working, but let's debug this one. So here, so that guy is the agent is 0. You can check with the gameplay debugger. And if we hit this guy, yeah, the active stopped. Okay, so it seems this is working fine. Let's go back here to the agent group. Sorry, let's go back to the task. So we need to spawn a new project. To do that, we can't do directly here because this logic is executed on a separate thread, so you don't have access to the full blueprint function, so you can't use the spawn actor directly here. In fact, if you search for spawn actor class, you see that you don't have that function here. But we can change data on the actor weapon group here, so we can basically pass data to the agent group, and then here on the event graph of the agent group we can actually spawn actor. So what we can do basically, so we can create an array of matrices where we store basically the transformation of all the new project that we want to create. So let's create a new variable here. Let's go create, I don't know, new project. This is editable, and this will be an array of matrices. Okay, so let's go back here. So here you can access the agents and also the agent group. So we can do a get agent group and we access the agent group. Then let's remove this one because I don't need anymore. Then we can cast this one to the weapon group. And then we can access the projectile here. This one we can break this. And then we can add a new item here. And then after that we set success. So we need to create basically a matrix that stores the position of the new projectile, and we can do that basically from the agent group here, get agents, and then we can take the transformation, get join or transform. JD, let's put the 0, and this is we need some offset here because otherwise we'll spawn at the root joints, and we need a transformation of 52.96 and 11.53, and then we can connect this one. And here we need to connect this one to the cast. The cast, go to the add. If the cast failing, set failure, and then set the state there. Okay, so this one should be ready. And then here, so we see that the agent, each agent that's fired will add an item here on this array. So we can, for example, use one of the agent group override, like for example the post and frame event. For example, we can get the array here, iterate over, here like this, iterate over each entry, and then when it's finished we need to clear, and then here can spawn spawn actor for class, and this one will be my first person projectile. We need to get the transformation, make transform to transform, and here, and let's add the owner, that is this one, get reference, self, okay. Let's save. Let's have a look if all works fine. Yeah. Okay, as you can see, there is already a problem here, because if I agent is hit by its bullet, it will basically decrease the health and then turn in a regular. Usually I want only that the will hit the agents. We can fix quickly this one. Just go to the enemy group, and here on the projectile here we can get the owner, and we can cast this to weapon group. Okay, now basically if the agent hit by a projectile that is created by an agent, then I don't want to modify the health. So basically I want when this cast fails, so when there is the owner of the projectile is not set from the weapon group. So if I do this one, let's save, and now yeah, you see, even if it's hit by another agent, it doesn't decrease the health. Okay, so seems all working fine, and then we can start to work on actual behavior tree of the mannequin.